Okay. Let's start this again. So, factoring. 2 times 24 is what Parker said is 48. Now here's where students struggle. I can understand this. It doesn't come as easily to some as to others, and that's okay. Not everybody is the same, and that's all right. And if it doesn't come as quickly to you, that doesn't mean you're dumb or not as smart. It just means it doesn't come as quickly to you. You need to find 2 numbers now to add to 19 that multiply to 48, and there's only ever one combination that works. Only ever one. Now, for those that do struggle, here's what I would suggest. List all of the factors of 48 you can think of, like 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. List them all. Do I expect you to know those off the top of your head? No, I do not. I expect you to use the tools you have been given. One of those is a calculator, the other one is a finger. Use the finger to operate the calculator to figure out what some of those factors would be. Any of those look promising? 3 and 16. Yeah, 3 and 16. Hey, this is a good start. All right, we're off to a good start.
And then you bring that with parentheses every
You say that again?
once you put in parentheses x plus and then x plus.
Yeah, it would be 2x plus 3x plus parentheses because it's 16x plus 3.
Would you reverse them to make it easier?
We have to split this 19x into the sum of those two numbers. Yeah. Yeah, you're right. The order of these doesn't matter. I could put the 3 here and the 16 here, or the 16 here and the 3 here. 16 matches maybe a little better with 2, so I can put the 16x first. So that's 2x squared plus 16x plus 3x plus 24. We now create a polynomial with 4 terms rather than a polynomial with 3 terms. Still looking familiar? Maybe a little bit? A little bit? Okay, good. Good, good. At this point, you put your pencil down and say, no, you persevere. You put a set of parentheses there, and another set of parentheses there. Good. Anyway, yeah, you know.
So would be, the length would be 2x.
X squared plus
That's the biggest you get, and then it would be x plus.
If you take the 2 out of the parentheses, that would be x squared plus.
You are going to take a 2 out,
And
yeah.
x out.
But you also notice they have an x in common as well. You got to take out the 2 and the x, so you're going to take out a 2x, and that leaves you with x plus 8.
So the other one is equal.
Now before you go on, you guys ought to get into this habit. Visually check this. Is this expression here the same as this expression here? How can you visually check that? Just distribute. That's going to give you 2x squared. That's going to give you 16x, which is the same as that. That doesn't take that long to do. It can save you making some silly mistakes. From this expression, take out a 3,
X plus 8.
and that leaves you with x plus 8.
And then we want to do x plus 8 right? 2x plus 3.
And then the last class, they use red. You should be using red. It's so much better than blue. I know, that's just for show. This is really 2 terms. This is 1 term right here. This is another term right here. This expression really has 2 terms. What factor do both of the terms have the same or in common? X plus 8 and x plus 8. So you take out the x plus 8 from both terms. Factor it out. Similar to factoring out these. So you factor out the x plus 8.
and you get 2x plus 3.
And once you take out that x plus 8 from both terms, you're left with 2x plus 3. And that would be impractical. Yay, you did it! Yay. Wasn't so bad, right? I remember spending a couple of weeks on that last year. Now we just spend a couple of minutes on it. And we're good to go. It's gonna dominate like the next 5 lessons pretty much. You have to be doing a lot of factoring. Alright. So let me have you try one on your own. Try this one.
Whoa.
Try that one. 2n squared minus 9n plus 10. Same procedure.
So 2 times 10 is 20. We need two factors of 20 that can add to negative 9. That's got to be negative 4 and negative 5. So you split that middle term into the sum of these two numbers. So it's 2n squared minus 4n minus 5n plus 10. Group the first two, and then group the last two. From the first group, you factor out a 2 and an n. That leaves you with n minus 2. Now, something you got to pay attention. This is just one of those things that you have to listen and remember and not forget and remember. Okay? This term right here, if it ever has a minus sign in front of it like this one does, you got to factor out that minus sign along with the greatest common factor. So you factor out a minus 5 instead of a positive 5. Because that's going to change that positive 10 into a negative 2, which will match this negative 2 over here. It's very important that these two parentheses match. If they are the same, you factor out the n minus 2 as a common factor, which leaves you 2n minus 5. Yay, we did it! Okay, I'm going to help you with a couple on your worksheet. So get your worksheet out. Question number 1.
Wait, which worksheet?
I gave you the worksheet.
No, you didn't.
Oh, I haven't given you the worksheet. Let's try this again. There is a slight difference in question number 1 here. Pretty important difference. What do you notice about all three terms? They all have the same variable, yep. What else?
No.
They're all even numbers. That's important to note, because any even number is divisible by 2. So we have a couple of common factors to factor out. 2x needs to be factored out before you can do the type of factoring that we just barely practiced. 2x comes out of everything. So we're left with x squared plus 5x plus 6. There you go. So once you've taken out the common factor, now you can factor the expression that remains very much like we did the other factor.
It would be so much easier to do now. So much easier. So what we're going for, you guys, just so you know, your answer is going to look something like this: 2x, and then you're going to have your two parentheses like this. This is what your final answer is going to look like. We just got to figure out what these two parentheses are, the 2x component. Okay? So let's see if we can get that. 2 times 3 is 6. Why do we just use a 6? Because on the other problems we didn't use the last number. There's a 1 in front of x. 1 times 6 is 6. Okay, so 2 times 3 is 6. 2 plus 3 is 5. So we're going to use a 2x and a 3x.
Wait, what?
2x and 3x. Because 2 times 3 is 6. 2 plus 3 is 5. We're still going to factor by group. Okay, from this one we factor out an x, that leaves you with x plus 2. From this parenthesis we factor out a 3, that leaves you with x plus 2. So then yeah, we are going to have, we're going to have an x plus 2 factor, we're going to have an x plus 3 factor. We're missing something. Dang it, where did it go? The 2x, there we go. Now you're your homework might not specifically ask for this, but I'm going to ask you, and I want you to put this. Well, I guess I don't want to put it anywhere, but I want you to pay attention to this. What are factors? When I say what are the factors of this, you need to understand what that word means.
Numbers that multiply together.
Numbers that multiply together to equal the products. For example, if I put a 12 up here, what are the factors of 12? 2 times 2 times 3. These are the factors, the prime factors of 12. Why are they called factors? What are we doing with those factors? You multiply them together to equal 12. So what are the factors of the thing we started with? This polynomial here, what are its factors? What is it that we're multiplying together? 2x is a factor, x plus 2 is a factor, and x plus 3 is a factor. How many factors are there? There are 3 factors. What's the connection? There are 3 factors. What's the connection to the type of polynomial we started with? There are 3 terms. That's good to know. It's actually the degree. What's the degree of the polynomial? Degree 3. How many factors did we get? 3 factors. Okay. I know it seems like, well, yeah, that makes sense. It's just a pretty important theorem. It's a part of the fundamental theorem of algebra, but that sounds really official, doesn't it? The fundamental theorem of algebra. That's part of it. The number of factors equals the degree of the polynomial. I want you to circle 5 and number 6. We'll do those a little bit later, probably on Friday. Make it a little more explaining. So let's try question 2 then. It starts much like question 1. There's a common factor. What is it? X squared. Let's check that. Do each of the terms have at least an x squared in them somewhere? Yeah, they do. So you factor out and x squared. What does that leave you with? X squared minus x minus 6, yep. And then you continue on your little factoring journey.
Not that I expect you to be to this point right now, but at some point very, very soon, you do need to be able to factor these sorts of things very quickly, because we're soon, I don't know if in this unit, but I know in the next unit, we're going to be doing problems where this is like 1 step out of maybe 7 steps to finish a problem. So if you're spending a lot of time just on factoring, you're going to be spending a lot of time on the whole entire problem. You understand what I mean? Yeah, this is meant, again, to be a review of stuff from last year. I can understand if it's a little shaky right now. Practice it. This is something that's meant to go pretty quick. What do you think? X minus 3? What's the other one? X minus 3, x plus 2. Now, I want to clarify something that I just talked to you about. That fundamental theorem of algebra where it says the number of factors equals the degree. This is a degree 4, isn't it? 4th degree polynomial. If you were just to glance at our result, this is the result. How many factors would you say there were? If you were just to take a quick glance. It kind of looks like there's 3, right? There's this factor here, there's that factor there, and there's that factor there. This one's a little unique though, right? It's got x squared. How many x's is that really?
2.
It's 2 x's. That counts as 2 factors. Okay? It's repeated. That's called multiplicity. This factor has multiplicity. So there's 2 factors here, there's 2 more, that makes 4 factors. Okay? What's that? Yep. This would be considered to have 4 factors. Let's keep going with this. Aren't we having fun?
Yeah.
You guys need to like calm down out there. You're having way too much fun. Yeah.
Can I just explain possible, or like how that's to be
It looks like this is only 1 factor, x squared. X squared is really x times x, so it really is 4 factors. But before you get too far into this one, let me at least head you in the right direction. What is it that we're going to factor out of this? They all have an x, that's true. They all have an x, that's good. Then -3. Okay, and that's just another one of these things that you learn along the way. If your leading coefficient is negative, for the love of everything holy, factor out that negative. It makes the factoring a lot easier. So we're going to factor out a -3x. We can't factor out an x squared from everything because this one doesn't have an x squared. It only has an x. We're going to factor out a -3x.